Hello, my name is Ron Clement from Sundance DSP. So far, you may have seen the videos on software, hardware setup, and videos on generating an application with 1 or 4 tasks targeting a single DSP. Here I will demonstrate how a 4-task application targeting 2 DSPs is generated in a very short period of time. The magic of PARS is that you can generate multi-DSP, multi-FPGA applications without writing a single line of C or VHDL code. Let's begin.
As before, we start MATLAB and then go to the folder where the Simulink block representing our application is kept. In this demo, we will be using an SMT395 VP30 and an SMT387 module as shown in the block diagram. By clicking the MDL file, a Simulink window will start and we can simulate the model to see it working under simulation.
The discrete Fourier transform of a real-valued signal is conjugate symmetric.
The model can now be closed after hearing the audio output of the application running under simulation environment. Run PARS in MATLAB window and then select the hardware we need to use. In this case it is named as SMT395 plus 387, which represents the set of an SMT395 plus an SMT387 module. PARS window will now show the selected hardware setup. Open the model from PARS and we should see the model in Filter Bank PARS 1, a new window. As we want 4 tasks, therefore we select some blocks and generate a subsystem out of them as shown in previous videos. Note the way that some blocks are selected and then under Edit we choose Create Subsystem. The model will end up with 4 subsystems and 2 blocks representing the audio input and output which are to run on the host system. Let's select the remaining 2 blocks and turn them into a subsystem as well. At this stage there will be 5 subsystems where one of them will target the host and the other 4 will target the 2 DSPs. A bit of rearrangement of the subsystems and renaming for more clarity is a useful practice. At this stage, one at a time, we select each of the 4 subsystems targeting the DSP and ask PARS to create a DSP task. The subsystem targeting host is then selected at the end and turned into a host task as shown. Note that all DSP tasks are green and refer to the root. I am going to select the 3rd task and change it so that it will not be placed on the root but on the 2nd DSP. Double-click on the 3rd DSP task and the Properties window should open. Go to the Place Task On and from drop-down menu select DSP-B. Click OK and then repeat the same for the 4th task. Save the changes and press the yellow button in PARS to generate the code. The magic begins and an entire application targeting 4 tasks to the embedded multi-DSP system will be created. Press OK when PARS is finished and run the application from the test bench. Remember, like before, for running the application on real hardware, the simulation parameters must be changed. Make the changes, then save the test bench for future reruns. Press play and you should hear the audio clip.
The discrete Fourier transform of a real-valued signal is conjugate symmetric.
This brings us to the end of this demo. For demos using FPGAs in conjunction with DSPs, please see the next video. Thank you for your time, and if you have any questions, please do contact us.